Hello dear students, once again welcome back to our channel. In this video, we are solving exercise 6.4 problem number 1. Okay, here it is given, let a triangle ABC similar to triangle DEF and their areas be respectively 64 cm square and 121 cm square. If EF is equal to 15.4 cm, find BC. Okay, and in the question what is given? Triangle ABC similar to triangle DEF. That is given. Okay, and areas of these two triangles also given. And one of the side EF of the second triangle that also given, and we have to find out BC. See children, EF and BC are the corresponding sides. BC and EF. Okay, so children, being it is given that they are similar, we can apply area ratio theorem. That is only for this area ratio theorem. In order to apply this area ratio theorem, the first condition itself, those two triangles must be similar. That is given. So, that is equal to the ratio of areas of two similar triangles. Okay, here that is area of triangle ABC divided by area of triangle DEF. Ratio means division. That is equal to the square of ratio of their corresponding sides. That means children, BC and EF, they are corresponding sides. So you can write it in terms of BC and EF. Okay, any of their corresponding sides, square of the ratio, any of their corresponding side, that is area ratio theorem. Okay, that is BC. If we are writing the triangle ABC in the numerator, you have to write its corresponding side as the numerator of the RHS also. Okay, so EF and its square. Now we are going to substitute the values is given there in the question itself. That means triangle ABC, its area is 64 divided by area of triangle DF is 120. When you are substituting the values, no need to write their units. After getting the final answer, you can write the respective unit. Okay. This can be equated to BC divided by EF whole square. EF we have given. EF is given as 4 whole square. Children, what is asked? We have asked BC, find the length of BC. So how this can be simplified? You can make this calculation easy. There are different methods. But when you look into this LHS part, here 64 and 121 being the square numbers. Okay, can you write this as in terms of 8 by 121 is also a square number. That is 11. Okay, whole square. Idea is clear, children? Okay, if you expand this 64 divided by 121, doesn't matter. Okay, this is already in square form, BC by 115.4 whole square. See, in the question we need only BC. Okay, that means if you take square root on both sides, okay, taking square root, okay, on both sides, square root of this equal to square root of this. That is, what is square root of x square? This square root and 2, that is square get cancelled and that is equal to x. We are applying this result, okay, in order to simplify. Okay, this question, that means this square root and square symbol get cancelled. In the same way, this square root and square get cancelled. Idea is clear because we need BC, answer in terms of BC. Okay, but here we have square. Okay, BC is in terms of square. Okay, square of BC. So in order to avoid that, I am taking the square root on both sides. So now we have in the next step, you can write this square root of 8 by 11 whole square, that is being it is get cancelled, it become now 8 by 11 equal to BC by 15.4. This step is clear, children? Okay, on both sides I have taken the square root. So we have now 8 by 11 equal to 15 BC by 15.4. Okay, in the next step I am keeping this BC alone by taking this to LHS. Okay, so BC is equal to, okay, 8 into 15.4 Okay, divided by 11. Idea is clear, children? Okay, I am keeping BC alone by taking this with 8. So 8 into 15.4 divided by 11, always in the denominator in this question. Okay, and how this can be simplified? Here also one clue, children. If 11 comes, 11 means it's a prime number. Okay, see that any one of the factor, okay, either 8 or 15.4 is a multiple of 11. Okay, that means you can easily get the value of BC. Okay, if so, children, 11 and anyhow 8 is not a multiple of 11, that we know. 11 in 15 one time, remainder is 4. Okay, then 4 will go with this 4 is in the decimal point, so I am giving 4, sorry, decimal point. So in 44, 4 times. Idea is okay, children. I divided 15.4 with 11. We have seen that 15.4, okay, is exactly divisible in 11 by dividing, okay, 11 in whole number part 15 one time, and we have 4 as a remainder, and 4 we are giving to the number in the decimal after the decimal point, so it becomes 44. So we have to put decimal point, and in 44, okay, this 11, 44, 4 times. I think the step is clear. Okay, now we have in the numerator, denominator get cancelled. Okay, one time, that is 8 into 4.4. How can we multiply a decimal number? Multiply without decimal point. 14 into 8, okay, 32. 8 fours are 32. Okay, 3 carries. Okay, 8 ones are 8 plus 3, 11, and 1 decimal point. Okay, so you can shift the decimal point from the right to left by 1. So 11.2, then you have to write the unit. While you are doing the calculation or the substitution, no need to write down the unit. After getting the value, final answer, you have to definitely write down the unit. So that means the length of the side BC is 11.2. Idea is clear, children? Okay, now we are moving to the second question. Now we are solving the second question. Diagonals of a trapezium ABCD, AB parallel to CD, intersect each other at the point O. If AB equal to 2CD, find the ratio of areas of triangle AOB and COD. That is the question. Okay, it's a very simple question, children. See, here ABCD is a trapezium with the ABCD is parallel. AB is parallel with the CD. Being it is a trapezium, surely one pair of opposite side must be parallel. Okay, here that is AB parallel to CD. And the diagonals BD and AC intersecting at the point O. Okay, we have to find out area of triangle AOB and area of triangle COD. First you identify, children, which are those triangles. You can see many triangles over here, but we need the area ratio between area of triangle AOB, this triangle AOB and COD. These are the required triangles. We have to get the ratio of areas between these two triangles. We have one more clue is given, AB equal to 2 times CD. We are going to applying this result, okay, in order to get the ratios of these two areas of these two triangles. Okay, yes, children, being it is given that AB parallel to CD. Okay, see, children, if you can show that triangle AOB is similar to triangle COD, you can apply area ratio theorem. Okay, so our first aim is to show that these two triangles are similar. Okay, and for that a very important clue, being it is trapezium parallel. Okay, one pair of opposite sides are parallel. That means you can apply alternate interior angles, corresponding angles. All those results you can apply in order to prove that these two triangles are similar. We are going to apply that. Okay, that means here the diagonal AC is the transversal. Transversal means the line which intersecting two lines. That means here, more than that, here it is parallel line. So their alternate interior angles are equal. The transversal here AC is intersecting the CD and AB. Two distinct points. That means this angle and this angle are equal. Why? Because they are alternate interior angles. Idea is clear, children? So for that I am going to consider triangle AOB and triangle COD, these two triangles. And we have what is the first result we got? Angle in terms of C in triangle COD. Okay, that means here OCD, C should come in the middle position. Okay, angle OCD equal to, in the second triangle, this angle and this angle are equal. Okay, and this angle is one of the angle of the second triangle AOB. So how can we write that one? Angle O, A should come in the, this is the angle mentioned. Okay, so AOB. What is the reason? In alternate interior angles are equal, or AB parallel to CD. This happened only because AB parallel to C, that is given. And not only this AC as a transversal, what about BD? This diagonal, this BD is intersecting these two parallel lines. That means here BD is as the second transversal is dividing these two parallel lines. That means here you can see this angle. Understood? That means this angle and this angle are equal. These two angles are equal. The same reason. Okay, and how can we write this? And also this is one of the angle of triangle COD, and this is the another angle of triangle AOB. Okay, so you can also write angle, first triangle that we have taken as COD. Okay, that means this is angle ODEC equal to angle, this angle can be represented as OBA. The same reason. This is enough by A similarity criteria. Or if you want this also, see children, what about these two? They are vertically opposite angles. Okay, that means I am writing that too. That is angle COD equal to angle AOB. Vertically opposite angles are equal, which implies triangle. Okay, being it is AOB is given in the numerator, I am writing that as the first triangle. Triangle AOB is similar to triangle. We have to write the correct symbolic form here. In terms of A, we can check. Okay, here A. Okay, this A and C. So C and vertical opposite angle O, and the last one COD. Okay, this is because of triple A similarity criteria. Okay, how we got this step is clear, children? Okay, these two triangles are similar means we can apply area ratio theorem. We have to find the answer in terms of ratio between these two areas of these two triangles. Okay, so in the next step, you can write area of triangle AOB divided by area of triangle COD equal to. Okay, I am going to write in terms of, okay, any square of the ratio of any corresponding sides, okay, but we have given AB and CD. See children, AB and CD are the corresponding sides. Okay, so you can write this ratio between the areas of two triangles in terms of the square of the ratio of AB and CD, being they are the corresponding sides. I am taking this ratio for equating these areas of these two triangles. Okay, and I am going to substitute here AB divided by, what is CD? Not CD, here AB equal to 2CD. Okay, so I am going to substitute here AB as 2CD. It is given, divided by CD as it is. I am not making any change for CD, and I am going to square them. according to the result, that means square of the ratio of their corresponding sides. So 2CD divided by CD whole square. Okay, that means 2CD whole square means 4CD square divided by CD square. CD square get cancelled. So this is equal to 4 by 1. Okay, so in terms of ratio, this is equal to 4:1. So we have now the area of these two triangles, that is in terms of ratio, that is area between triangle AOB divided by area between triangle COD equal to 4 divided by 1, that is 4:1. Okay, third question. In figure 644, ABC and DBC are two triangles on same base BC. If AD intersects BC at O, show that area of triangle ABC divided by area of triangle DBC equal to AO divided by DO. That is the question. See, here in this question is very important. It is not given that this quadrilateral ABCD is not a trapezium. Okay, ABCD is not a trapezium. Nothing is said about this. This is what type of quadrilateral is this. The only thing is given, we have to concentrate on two triangles having on both the base are the same. Both triangles are on the same base BC. We have to just concentrate on that idea only. Okay, and these two diagonals of this quadrilateral ABCD intersect at the point O. These are the only two conditions given. Okay, triangle ABC, this triangle, okay, and triangle DBC, this triangle are on same base BC. So look into these two triangles separately, this one and this side of the BC, DBC. Okay, so and what is asked? That question is in terms of areas of triangle ABC divided by area of triangle DBC. See children, you can apply only the area ratio theorem only when if you can show that these two triangles are similar. But in this case that is not possible because nothing said about the type of the quadrilateral. Okay, children, this is a transversal, but you can mark alternate interior angles are equal only when a transversal cuts two parallel lines. It is not given in the question whether AB is parallel to BD or not, or AB is parallel to CD, that is not given. So how can we take that result? Okay, but at the same time we should get that answer in terms of this ratio between areas of triangle ABC and triangle DBC. So the next possibility is you get the area of triangle ABC by using the formula half into base into height. Okay, for both the triangles being on the same base, okay, so half get cancelled if you take the ratio between that areas. Okay, and in the RHS you will get only the answer in terms of their height. That is what I am going to do for getting the answer for this question. Okay, so I am going to apply area of triangle equal to half into base into height. So in order to apply this formula we have to first draw the height of both the triangles. Okay, so triangle ABC, height means the perpendicular from a vertex to its opposite side. So I am taking a vertex A to its opposite side BC is a perpendicular 90 degree. So let it be AP. It's the altitude, height. So in triangle DBC we need the height of triangle DBC. So from the vertex B I am drawing its perpendicular towards its opposite side BC. Okay, so this is that height. So this is the height of the second triangle, that is let it be P, this is M, we have taken this as P, so I have marked that height of the second triangle DBC as M. Okay, so I am going to apply this formula in order to get the areas of these two triangles. So area of triangle ABC is equal to half into base into height. Base, both the triangles on the same base BC, and height for the triangle ABC is AP. And area of triangle DBC equals, same formula I am going to apply, and second triangle also on the same base, okay, BC. So you can mark, substitute BC as it is, okay, and its height is from D to BC is DM is the height, altitude DM. Understood? So here being it is 90 degree, you can mark that is 90 degree, okay. So here in order to get this in terms of ratio, I am going to divide these two equations. Let it be equation number 1 and equation number 2. So 1 divides 2 implies, you can divide, okay. So in LHS it will be in terms of area of triangle ABC divided by area of triangle DBC equal to half get cancelled, common base get cancelled. Now we have AP divided by DM. See children, how we started, we applied that formula half BH, and now we have the ratio between these two triangles in terms of ratios of their corresponding altitude. That is the way we reached now. And what else we need to prove? See, in the given proof, here it is in the RHS, AO divided by DO. Here we got AP divided by DM. So our next aim is, okay, to show that AP by DM equal to AO by DO. If so, you can write this areas of these two triangles, the ratio between these two triangles is equal to AO by DO. It is clear children? So, see children, here in order to prove that, okay, I am going to consider, see children, here AP and DM, okay, are the sides of the triangle APO. Okay, here DMO. Okay, so I am going to consider these two triangles. Okay, so consider triangle APO and triangle DMO. Okay, see, can we prove that these two triangles are similar? If so, you can write their corresponding sides are in the same ratio. Okay, see children, APO and in triangle DMO, these two angles are 90 degree. That means angle APO equal to angle DMO, that is equal to 90. By construction, we have drawn the perpendicular height. One more angle, if you can show that they are equal in both the triangles APO and DMO, you can say that these two triangles are similar under AA criteria. See children, these two sides PM and this side get intersected at the point, that means this angle and this angle are vertically opposite angles. Okay, and those are the angle, these two are the angles on these two triangles. So that means angle AOP, this angle, equal to angle COD, this angle COD. That means triangle APO similar to triangle DMO. See that the correct symbolic form, whether they are in correct symbolic form. Let us see. Here P 90 degree, P, here M is 90 degree, no problem. And so the second position, O and O in the third position, being they are vertical opposite angles, I placed O in the third position, here also O third position. So the vertex A and here D. Okay, so they are similar under AA similarity criteria. If so, the corresponding sides are in the same ratio. Okay, since being they are similar, I am not applying area ratio theorem here children. Okay, see AP divided by DM equal to OP divided by MO equal to AO divided by DO. Yes? See children? That means, why? Because this by CPST, corresponding parts of similar triangles, corresponding sides are in the same ratio. Now where we have reached? Okay, see children, AP by DM, we got an equivalent expression to either OP by MO or AO by DO, but we need these first and third relation. Okay, you can write DAP by DM is also equal to DM equal to AO by DO. We need this. Okay, so I am going to substitute here, that is for AP by DM, I am going to substitute this is equal to AO by DO. Equation number 3, okay, here as equation number 4. Now this become AP by DM can be replaced with AO by DO, okay, from 4. Okay, so in the LHS you can write area of triangle ABC by area of triangle DBC is equal to AO by DO. Okay, this is the required result. I hope this step is clear. It's very important question.